the fire service tends to be enamored with, what color red chip they want on their new fire engine. And rightly so, because, they cost $1 million now. So the attention goes there. It doesn't go on the details, right? And it's really just plumbing. Open it up and take a look at it. And, very few firefighters, I think, look at the fire engine that way. Water comes in big, we reduce it down, and we regulate pressure with a nozzle. It's plumbing. It's not that confusing. Forget about how pretty it is. Let's take a look at where you can make a mistake that makes somebody hurt, burned, or dead. That's what we have to get right.
This is another episode of Recon Live. I'm Bruce Quick alongside Jason Whitmire. And before we get started on today's topic and guest, let's do a few housekeeping items. If you haven't already, make sure you follow us on social media. You can find us on Facebook and Instagram. That's at Recon. You can catch this podcast wherever you catch your podcasts, including YouTube. Make sure you subscribe, hit those post notifications so you know when every new episode drops. And then most importantly, visit our website, rigrecon.com, for all the latest apparatus information. You can truly become an apparatus expert when you visit our website. Before we get started, this episode is presented by Elkhart Brass. Since 1902, Elkhart Brass has been committed to creating quality fire equipment products and serving the fire industry. So, Jason, legendary guest on today, Jerry Herbst, works with us here at Elkhart Brass. And Jerry, I won't do any justice in introducing you, so why don't you tell the audience a little bit about yourself and your history and what you do for us here at Elkhart Brass.
I'm a fireman and I'm old.
Perfect. Cut and scene.
Yeah, no, I've been, this is my 20th year with Elkhart. And my presence is really driven in the field for the most part. I do a lot of hands-on events, a lot of trials with our major urban customers that can be quite lengthy. I'm fortunate to be able to teach on the circuit quite a bit and interact with a lot of firefighters through the course of a year, telling, our message about accuracy and, the know your flow mantra, that type of a thing. My fire service career is 46 years, both paid and volunteer. Still volunteer now. So that's an asset. Most of our field team has been involved in the fire service in one way, shape, or form.
Jerry, I asked Andy when he came on this question. I want to ask you as well. Was there maybe a particular moment or something you can reflect back on where you knew like you were just going to be involved in the fire industry forever?
That was kind of a legacy thing. My father and uncles and that type of thing were involved with it. The service aspect of it is there. It's difficult to make a decision to commit to, a total career as a firefighter. I had a very, a strong appreciation for the business world too. So you kind of run them in parallel, but very early on, it's just the excitement of it all.
Sure.
It attracts, most young kids.
Yep.
It kind of hooks you at a very early age. And then once you get involved, there's events that happen that, drive you towards being better at it and staying with it.
No, we always pick on age, and I'm not going to say you were around in 1902 when we started, but I am going to date you a little bit. Part of the excitement was riding the back tailboard, because I know when you started that was going on yet.
Yeah, without a doubt. Yeah. And, it's funny. I sometimes put up, when I get Chris back into the field to teach with me occasionally, we'll put up pictures of us both like in our, first year, and mine's in black and white. But the rear step was thrilling without a doubt.
Yeah. And the only reason I dated you on that is because I rode the rear step as well. So.
No, I got on in 79, and, it's funny on the fire service side, I think I've been in probably like the best block of time with the changes that have happened. And it's just, it's the concept is the same, the approach is the same, but what we work with now compared to what we used to is just unbelievable.
Yeah. So know your flow. You guys do a lot of know your flow classes. You are the king of know your flow here. Just roughly for our audience, roughly how many classes do you do a year on know your flow?
Oh my gosh. Combined with conferences and everything, I don't know, probably 70 or 80.
Nice.
Yeah.
So there's a lot of know your flow going on out there. We're going to talk a little bit about know your flow today, but we're going to turn it to the rig side more.
Sure.
Because I think a lot of people, I know in our industry or just inside our own company, when people think about know your flow, it's, oh, I'm going to go out and do a know your flow because I'm going to sell them a nozzle, or I'm
Yep.
going to teach them how their nozzle works with a specific hose package.
Yep.
We can take it all the way back to the rig.
Yep.
And us old school guys, when you made a flow chart back in the day, you pulled out the book or something that came with your hose that said per 100 feet, you have this much friction loss.
Yep.
And you said, I know that nozzle, I want to flow it at 165 gallons a minute. It's 200 feet. Here's the math. I need this pump discharge pressure.
Yep.
Talk about how that's changed and how a know your flow class can really teach you. It's much, I don't want to say it's much better. That doesn't sound right, but it's much more effective to actually set up a flow meter and do a know your flow and learn the flows on your specific rig and why that's important.
Yeah, it's imperative. I was smiling as you say that because really, literally, that's what people do and still do. It's like you can go into the back of the Elkhart Brass catalog. Now we don't make hose, but there's estimated friction loss per 100 feet at whatever flow and pressure. And that's very rarely validated. If somebody just does simple math, everyone in $1.20. If they want more, we'll go hands up, thumbs down type thing. So know your flow is a generic term for a lot of different things, but the core objective of of a class is to talk about the importance of accuracy, interweave the reality of the fact that it's human error is usually the problem. It's at the beginning of any class, I'll ask the entire room who's been on an overpressurized line. And who's been on an underpressurized line, who's pumped a fire, who's made a mistake pumping a fire. And literally every hand will go up for all of those. But none of that was an act of a supreme being. A human made a mistake. And, hopefully nobody got hurt, burnt, or dead. But the accuracy nowadays, because of the change in the fire dynamics, is critical. So the Know Your Flow talks about probably more than anything, the relationship of the nozzle firefighter being effective at their job. And, it has to go into all the things that are part of that. It's basically from the hydrant to the fire. And everything has to work in sync. I think probably part of the issue is the older firefighters, like myself and you, Jason, is we were thumbprinted wrong. We were thumbprinted with pressure rather than flow. We equated, a rigid line to attack capability, and it could have been flowing 90 gallons a minute. So once we break down some barriers in the class before we actually go out and do what we're going to do, is just to get everybody talking the same language and to understand, okay, there wasn't always governors. It was just a vernier throttle, that type of a thing. And a lot of things that can combine to make major errors. A good example of that is I talk about presets, right? I've actually talked to engineers on a fire engine that has 3 different length pre-connects, but only one preset. And I ask them which one it's set to. And I get a deer in the headlights look. Well, you got a 100-foot bumper line, a 150 and a 250, and you're only using one pressure. Which one was it validated on? What length? Because it's going to be a different number. And that type of a thing. Or, you blindly ask, hey, what's your target flow? And the answer with the pump discharge pressure. So a lot of things are taken for granted. And the class is designed to say, we need to be a little bit better at this. We need to be aware that the human element is probably the biggest driving thing that creates issues. And that an understanding of the entire system is imperative at the firefighter level. And that's the firefighter, the driver, engineer, the chauffeur, whatever you want to call it. The boss, everybody on the rig has to have that sense of ownership, but really understand it, because if it goes sideways, you never know what position you're going to have to put yourself into.
And Jerry, I want maybe talk about the structure of a Know Your Flow class. I know we really get educational with it. It's more than just setting up lines and going and figuring out there's classroom time. You guys are intentional in how you present the message. For me, I've seen bits and pieces of Know Your Flow stuff, but when we're at Water on the Fire was like my first true A to Z Know Your Flow class, and it was pretty compelling, the amount of detail and work that you guys put into something like this.
Yeah, and that's purposeful. I think any instructor or presenter has to be able to break down some barriers and be human. Teach within their own personality. So I talk about errors that I made as a firefighter, and that I think puts a group at ease.
Right.
It's just firefighters talking. I intentionally try and keep it design driven, not brand driven. I mean, it's obvious why I'm there, and who I work
Right.
for. But we don't want it to be about product. We want it to be about the interaction with the product and the firefighter. Truly, we make probably one of the few very emotional products. Okay.
Sure.
And when I say emotional product, a firefighter's weapon on an engine company is what they fight with is water. It's hose and a nozzle. And you really, you need an intricate knowledge of that from a design standpoint, right? You learn it in a very controlled atmosphere outside. It's used in total chaos.
Right.
And so that the classroom portion is designed around that reality. We go deep into the animations of the nozzle design, right? Even a smooth bore. There's things, we kid around and say there's a reason we put open and closed on the bail. All right. Some firefighters are challenged with that, right? But most firefighters see either smooth bore and fog. Well, in a combination or a fog nozzle, there's three primary designs. Which one do you have? The old school firefighter looks at it. If it has a bumper, it's 100 PSI and that's it. Is it a fixed? Is it a selectable? Is it an automatic? What are the positives and negatives of each design? And, when you start to look at it, and the animations that we have in Brass Tacks Hard Facts are tremendous. It shows the water flow through. You can pause it, can stop, talk about, what happens hydraulically, talk about overpumping, talking about underpumping, the impact that it can have. And, I think that gets everyone thinking the right way so that, when you do transition outside and, the Know Your Flow portion is basically a mock of a 1962 rig flow test. We're going to put flow meters on. We're not going to do any guesswork. We put gauges in a bunch of weird places to find loss that people never take into consideration. And it's a real epiphany. And oddly enough, I at the beginning of every class, I do what I call a class demographic, how many 0 to 5 years, 5 to 10, so on, and how many are bosses. And usually it's as heavily weighted at the senior or boss level as it is at the newer firefighter level. And that's good because it's probably more of an impact on the older firefighter who was thumbprinted incorrectly.
Sure.
The old 50, 80, 100.
That's it. Yeah. Pump at 150, make it 350. You pick the one, there's just too many of them. Literally like the first fire I pumped, I sat there with my hand on the vernier throttle and I'm looking at the guy at the door. And when he started going up, like he was going to lose it, that's where he stopped. There's nothing scientific about it. And that was to get 90 gallons a minute,
Right.
So when we talk about apparatus design, a lot of times people don't understand what goes on inside that pump house. So they think of it from the end of the connection where they hook the hose up, and they're considering what we talked about in the beginning. What do I need at the tip? How long's the line? What's the friction loss?
Yep.
What I found very interesting in one of the first Know Your Flow classes that I took part in was we hooked up to the 2 cross lays. Mm-hmm. Now, if you look inside the pump house, those cross lays, there's a chick sand swivel on there typically. There's a lot of bends in that plumbing to get up there. Yep. You can spec it however you want. You can say, hey, I want no 90-degree bends. The plumber's going to look at you and chuckle and say, okay, I'm going to put a whole bunch of 45s in there, and you're still going to have probably more bends than that 190.
Yeah.
But talk about building a flow chart and how you systematically go around the rig and flow a line and help someone build a flow chart that they can have that says, okay, I know that crossing number 1, I need this pump discharge pressure to get my desired gallons per minute.
Yep. It's once you're set up, it's easy to do. To explain the setup, and that's we use the class to help set it up. Everybody knows there's a master discharge gauge and a line discharge gauge on a fire engine, right? Where the big gauge is the master discharge gauge, the line gauge is the smaller one. And you start with that dialogue about, okay, we trust our gauges. It's your fire engine. You always think they're right. That's not necessarily true. We're all taught that the line discharge gauge is probably more accurate for the line you're supplying because of where it's tapped, where it's getting the reading, right, in the outlet behind the pump panel before it goes into the hose. But inevitably, you're taught that, but you watch somebody on a one-line fire and their head goes up, so they're looking at the master discharge gauge. So we want to capture the difference between those two because it can have a severe impact on the total flow. So we would keep track of that. You mentioned the chick sand swivel. We would put a gauge on the top of the chick sand swivel before the hose. And what we measure there is the difference between that gauge and the line discharge gauge is plumbing loss between those 2 points. If you have 2 crosslays on a fire engine, it's not uncommon for them to be plumbed completely differently. You might have 390s on one and some flex hose on the other. The real estate available inside of a pump panel is there's not a lot of it.
And it's shrinking.
It is. And, you mentioned something about specking, no 90s or specking loss between 2 points. A lot of people don't do that, and they should. Because if you've got a 10 PSI differential and they sit right next to each other, you're pumping them with the same preset. You're pumping them at the same number and you're not getting the same water.
Right.
And it gets really crazy if you're pulling from the front. Normally, rear pulls are kind of simple. You might have 1 or 2 elbows and a straight shot to the back. But, a front bumper, you've got multiple elbows, flex hose going over an axle. In my volley department, we had a couple, we pulled structural lines from the front of 2 engines that we had. And you're talking like 20 to 25 PSI loss between where you're making a decision where water actually goes into the hose. So we track the master gauge, the line discharge gauge. We note the difference between those so that if you are pumping the master gauge and you should be pumping the line gauge and there's a 10 PSI differential, you're under pumping by that line by 10 pounds. Capture the plumbing loss. That right there is the 2 things that you don't see. That the fire service tends to be enamored with, what color red chip they want on their new fire engine. And rightly so, because, they cost $1 million now. So the attention goes there and it doesn't go on the details, right? And it's really just plumbing. Open it up and take a look at it. And, very few firefighters, I think, look at the fire engine that way. Water comes in big, we reduce it down and we regulate pressure with a nozzle. It's plumbing. It's not that confusing. Forget about how pretty it is. Let's take a look at where you can make a mistake that makes somebody hurt, burnt, or dead. That's what we have to get right. So master gauge, line gauge, what we call the rig gauge would be on the chick sand swivel or before we get into the hose. And let's say it's a 200-foot pre-connect. We would put a gauge at the midpoint so we can take friction loss in that first 100 feet and then one at the base of the nozzle. So we now have friction loss in the second 100 feet, and we also have base nozzle pressure. It seems like a lot, but what it's designed to do is if any particular portion of that looks weird or is coming up with numbers, you retest and you validate, and then you just break down, okay, maybe it's a hose liner in this particular 100 feet. Right. It narrows down where you have to solve problems. But, when we do that, let's say I'm working with somebody that wants to do an evaluation of different nozzle designs. We would set the rig up that way. And I would ask them, I said, just go to the pressure you would if we pulled this line at a fire right now. And that gives us the baseline. So we know what their target flow objective is. Now we find out whether you're hitting or not and where we can find out what we can do to help it, right? If it's 100 PSI, maybe they want to consider a lower pressure, that type of thing. But if you don't set it up correctly, you can get that baseline information. You're dealing with opinions and emotions, not facts.
Yeah.
So, the myth buster is the flow meter. We stack the gauges, we test them all in front of everybody. So if they're all within a couple PSI, that's good. We calibrate the flow meter every time we use it. So we know our equipment that we need to validate is accurate.
Right.
And most people don't do that, right? And very rarely, does a fire department meet the 1962 hose and nozzle testing standard. But, it changed years ago, and every pre-connected attack package on a fire engine is supposed to be tested annually, records kept. It has to flow what the authority having jurisdiction says it should flow. And even if it's modified throughout the year, it's supposed to be retested. Very few people do that. But that's the value of doing it with that fire engine that day, right? If they have 10 different engines and not a very, very tight spec, with loss in the piping spec when they order it, every engine is probably going to be a little bit different. It's larger jobs tend to have tighter specs because they usually have fleet chiefs and officers that do nothing but spec apparatus. But that's not always the case. But,
Right.
It's not uncommon to see, hey, I've got a Rosenbauer, I've got a KME, I've got, a Pierce, I've got old, I've got, brand new. And you pump them all the same, and you're doing yourself a disservice by doing that. Older rigs tend to be, I think, a bit more accurate because there was less involved. There was more hard piping and there was more room. But it's not uncommon to see two rigs come on the same PO and the plumbing is completely different.
Right. Can a department build a flow chart on their own if someone didn't come in to do a know your flow class?
Absolutely. There's lifelines. They could go to Brass Tacks Hard Facts. They could talk to someone who's done it. The key is to get the right equipment. We do this frequently. We've got this, a demo cache where we send equipment out. You don't have to buy it. It would be great if you bought it. But identify how many weeks you need for to do your testing, and get the gauges and the meters and the pitot so you're doing it accurately. We provide all the resource on how to calibrate, and obviously the guys are always taking phone calls. Hey, it's like diffusing a bomb, the timeout on the meter, I can't get it right. So we work through that. But yeah, it can definitely be done by department. It takes time, it takes work. The one thing I strongly encourage when I'm working with an end user is they need to have a target flow by line size in print. And very few do. So you have to have a target. And, the testing that you want to do to build a pump chart is all to achieve that target flow. Right. And it's flow driven as opposed to pressure driven. So yeah, they can set up the same way we do and do it. And that's what we would encourage them to do. It's probably less threatening if they have somebody. There's usually one or two guys in a firehouse that are into hydraulics. They're into this kind of stuff, and let them do it. Get them the equipment they need to do it. Give them the objective, and then just let them go out and do it. It's a long day if you're going to do an evaluation of different hoses and nozzles and all that. Just to get a pump chart, it's intriguing, and I think one of probably the silver lining to it is that flow meter is for more than just testing. They'll find value in that if they have a flow meter or purchase a flow meter and start teaching their drivers with a flow meter, they'll be flow conscious as opposed to pressure obsessed.
Absolutely.
Yeah. And there's a lot of value in that. So yeah, we encourage it both ways. If you don't have the talent in house and, you want someone to, as an SME or subject matter expert, that's where our field team comes into it. Yeah. But it can most certainly be done, especially just to build pump discharge pressures. What I think people aren't prepared for is the fact that, okay, if I've got 10 engines, I might end up with, 6 different pump discharge pressures.
Right.
The preset is not the answer to everything per se. But every rig's difference in piping and where you pull from is going to have an impact on it. It would be great if you could have a standard pump discharge pressure for a standard hose size. And if they're all close or within 5 PSI, 5 GPM, you probably could. But, taking that whole approach, like I mentioned, it's a combination of errors. It's like I mentioned the movie The Perfect Storm, right? You got this badass boat captain, some senior people on his crew, some new people on the crew. It's just like a fire company, right? And they're out there and they get, clouded by the big haul of fish and they're not paying attention. And, Anyway, there's this massive weather system, and at the end of the day, they're all dead. Right. So it was just a combination of errors. And when something goes wrong in a fire, it could be the same thing. Oh, the preset was set to the 150 on the bumper, not the 250 we just pulled. We miscalculated our friction loss because we went to a chart and never put a flow meter on it. So our PDP was under pumping your 7/8 by 20 gallons a minute, and you were looking at the wrong gauge. All of a sudden that 160 that you thought was your target is 125, and you're pinned to the ground, sticking to the carpet mat. That's it's just a combination of things that accumulate.
I will say a lot of the flow classes that I was involved in, it's not a knock on the fire department. It's not saying anyone did anything wrong, but typically when we would go out, we would set up and say exactly what you said. Drop your line, pump it like you normally would. Pretend you're at a fire right now. And then we'd show them that flow meter and they go, no way, I'm flowing a lot more than that. And we're like, no, you're flowing like 90 gallons a minute. You're flowing like 110 gallons a minute. It's not enough to put the fire out.
Yep.
And again, it's not that they didn't know what they were doing. They just never had the equipment to really test it and learn and see that they needed to do it different, or they needed a different nozzle package or a different hose, because a lot of people are using 20-year-old hose out there and it wears. Yeah.
And, the mixed hose fleet, especially in larger jobs, is probably the single biggest contributing factor to those errors. It's no revelation, I think, to anybody, unless they live under a rock, that, 1.75 isn't necessarily 1.75 in diameter under pressure. They have a true ID now that is, that acts more like, the old double jacketed canvas stuff with brass couplings that we started with, because the sidewall is so durable. But, you're right. It's non-confrontational so long as you explain the equipment and why it's set up that way. The value, I think, of the firefighter interacting with the nozzle design goes back to what you're talking about. You've always done it this way. You could talk to me if I was into this and say, I've been pumping that engine at 120 for 30 years. Now you're here to tell me it's wrong. No, but I'm going to tell you what it flows.
Right.
And then, once you're set up in that arena, here's the other value of the equipment. You put the different design nozzles on it. So, a smooth bore or 50 PSI fog has a set amount of nozzle reaction based on calculations. The exact same flow at 75 or 100 is uncomfortable to hold on to. And that's where you show those comparisons. The other thing that's really valuable is do what I call a go, no go. And let's say you take an automatic. It's still very popular nozzle. You'll find a lot of them, usually older, in service on fire engines. And once you've in the classroom explained how that spring is designed and what it actually does, you go out and you set that at a target flow of 160. Let's say it's 150, whatever it is you want to flow. And then I have eyes to the chauffeur, and you tell the firefighter, you let me know based on what you see for stream reach when you wouldn't go into a fire with it. And I have them start lowering the pressure. And if you're at that 150 or 160, they usually don't catch the visual impact difference in the stream until it's around 70 or 80 gallons a minute. And that doesn't mean that the design is wrong. It doesn't mean it's a crappy nozzle. It means that it takes away the visual that a firefighter needs to say, I have adequate water, because that spring is maintaining what? Stream integrity and reach.
And it's doing what it's supposed to.
Exactly. It's designed to do that. So then you follow up with a question is, okay, how long do you actually bleed the line at the door? Air's gone, you haven't caught a fire in a while, you're gone. And you could be flowing 70 gallons a minute and not even realize it.
Right.
It could have been a mistake at the pump. It could be caught up under the wheel of the rig. But when you look at the design of a nozzle, there's a positive side and a negative side. What is it? And then you relate that to your reality. Okay, do I want to take away the visual indication that I have a compromised supply? Probably not. So that design is no longer viable for you. So when you start looking at that design and how the firefighter impacts with it, I think it draws people to conclusions that really make sense. Because the whole objective is an effective firefighter at a target flow.
Right.
And, the other thing I think in the class I definitely hit very heavy is, with my acronym of CPR is the confidence to pursue reality. And the reality is one firefighter needs to be able to manage that nozzle reaction at your target flow. And usually not your rock star. You might be working, with mass malfunction Mikey. So, It's got to be, the B shifters need to be able to hold on to it too.
I'm gonna shift gears a little bit. So one of the other classes that you teach a lot is high rise or mid rise type classes. We do some specific products. Elkhart has put together a nice package for those types of incidents, but I think a lot of people don't understand or how a standpipe works is probably very misunderstood in most fire departments. One of the first things I learned from you was when they're putting that building together, talk a little bit about how those standpipe risers are and how that flow restriction and the different valves and where they're installed and how mistakes can happen.
Yeah, it's wrought with the probability of mistakes. I think the first thing you need to realize is it's not really there for us. It's there because a building asset owner wants to make money and needs a certificate of occupancy, so it has to have it. Whether it, there's a myriad of different types. Is it just sprinkler? Is it fire department outlets? Is it a dry system? Is it a wet system? Probably too much to talk about here, but you need to understand what it is you're working with. The valve identification is critical for the working firefighter because I try and frame it this way: the person who sets up that outlet is the pump operator for the fire floor, and your entire fire engine is in a bag this big. So you need to know what you need ahead of time. Are the threads the same? Do I need adapters? They're 9 times out of 10 probably vandalized to some extent. Can you overcome that? And then to understand the type of valve that you have. And you're right. It's a great big black hole for a lot of firefighters. They're very well attended classes. They can get very deep. You can, the system design is driven by NFPA, obviously. You need to understand, how it's changed. We talk about there's a pre-93 and a post-93 outlet pressure standard on a pump system. A lot of people don't realize that. If you've got an older infrastructure with a lot of pre-93 standpipe valves, the outlet pressure standard at that point in time was 65 PSI, which is 3 pieces of 2.5 with a inch and 1/8 smoothbore nozzle flowing 250. That was the target of the standard. Horrible fire in Philadelphia. The post-93 standard for outlet pressure has gone up. So if the authority is adopted that standard, it's 100 PSI outlet pressure. So you have more to work with. But the valve identification piece comes down to you think you're always going to get water, and that's not necessarily the case. If it's just a straight angle valve, which is very simple, those are normally found on, dry systems, but on the upper floors of a building where there's not a lot of pressure because you're not close to the pump. And then, you'll have probably all 4 different designs somewhere in that building. You'll have PRDs, which is a pressure restricting device, something that can be overcome, or a PRV, a pressure reducing valve that is factory set, which you can't overcome, or an adjustable PRV. So the deep part of the knowledge curve here is you not only have to understand the design valve, but who made it, because your brand makes a difference. Like our particular valve, you can overcome it one way, and other manufacturers is a different way. So there's a lot of pre-planning involved with that type of a thing. But
one of the things that jumped out at me was, I don't think, sure, in your big cities, your professional departments, they're inspecting these things, they're looking at them. In my little volunteer department, half my guys don't know what's going on in there necessarily, and that's not to their fault because we don't run a lot of calls at that type of building.
Yep.
But man, when we do, the biggest mistake that I remember hearing in one of the classes was, so if you think about how that standpipe design is done, there's different floors, there's going to be different pressure. I'm going to have different valves for each floor. So I'm building the building and it's 8 stories. And
Yep.
Someone says, okay, this is the valve for the 8th floor. This is for the 7th. This is for the 6th. And they lay them on a pile on the floor. And now some guy goes to assemble it. And by accident, he puts the 1st floor valve on the 8th floor and vice versa, the 8th floor valve on the 1st floor. Well, now it's radically going to change the pressure coming out because he's got the wrong valve there. So he may be over reducing or under reducing. And now there's too much pressure. If I don't find that until the day that someone's trapped and I'm at a fire, I got a big problem.
Yep. It's a bad day. And you mentioned your reality, right? And that's the definition of this type of fire is low frequency, high probability for error. And a lot of it comes back to the understanding the system. Is it simple? Is it a sprinkler system, or is it a combined system? Is there standpipe outlets for firefighting? Is it dry? Is it wet? Is there a pump? Is the pump working? What if it's not? What do we do? And a lot of people will just go pump into the first floor. Well, if it's a pump system, the first floor is probably going to PRV, and that's one way only. You can't pump into it. So those little things are the things that make it a bad day. It can get too deep. We're in the process of releasing some brass tacks hard facts now with the right guy. We use Kyle Smith and he sits on the committee. We sit on the committees, right? His side hustle is this type of stuff. And one that we're going is, you're the firefighter on the day, you're detailed to the pump room on the day of the fire. What do you do? What do you need to know? What you got all these pipes and valves, they can be your friend if you know what to do. If all of a sudden you have a pump failure and you have to pump the system, there's a way to do it. You have to know how. And that doesn't mean, we're just going to go to the first floor and pump into it, because you probably won't be able to. But it's an area that, unfortunately, I think people don't think about until they have it. And then all of a sudden it goes bad. Our approach to it, like when I teach with a couple different groups, and when we're doing this portion of it, I'm involved with the bag. What is the bag, and how is it your solution that day? Because literally it is, if you're the control firefighter, the person that's going to set up the valve, that bag is your fire engine, and you are the pump operator for the fire floor. Right. And there is no presets here. This is, you're going to set flowing pressure, which, old school firefighters understand that term, which means even if you're in a hallway that isn't on fire, you're going to flow water to make sure that they have an effective fire stream prior to entry. So all those things work into it, but what you try and replicate there, why we advocate for a gate valve, why we advocate for elbows, why we advocate for gauges, is because you have to function as the pump operator off of that outlet. And you need to be in control of that, a very tight control. And the one thing you get in the street that you won't there is a second chance at setting that pressure. And if you assume that it's correctly and you don't have a gauge, down your thumbs up and thumbs down on what could be a marginal supply system. So it's, if you look at it the right way, the equipment orientation, probably one of the most powerful things when I do a systems to the stream or a standpipe type class is valve identification, how to interact with them. Can they be overcome? How do you do it? What tools do I need? And that's studying your district. But like you say, you don't have a high-rise exposure, but if you've got a Hampton Inn or a Home Depot, you've got a standpipe. Large areas, tunnels and things like that are horizontal standpipes, single story, warehousing, and that type of a thing. You need to be familiar with it.
And you talked about it a little bit already, Jerry, in the special equipment that you need to consider and the fire company should carry. So maybe go deep into that and sort of what Elkhart Brass offers from that standpoint.
Sure. What goes into your bag is going to be regional to what you respond to. If you're a downtown company in an urban area, a lot of downtown companies that go to a decent frequency of work or have a particular hose cabinet where that valve is, might carry two elbows. And that's only because the orientation of the valve in the cabinet requires one to get out of it and another one to take the vent out of the hose. And then, one of the things that you have to take into consideration is you're going to want a lot of things in the bag, but you can't carry it, right? It's carried by one firefighter. And, on a busy company, many times during one shift on smells and bells that aren't fires, and you're going, you're up and down with this bag. So the person who doesn't want to carry it is the one who wants to put all the equipment in it. So he's not the guy who's going to carry it. But what you want are things that are game changers for the day of the fire. The gate valve is in our estimation critical. People say, why do you put a valve on a valve? Well, if you think about, you pull it, you come up to this valve, it's vandalized. You have to overcome the fact that there's no handle on it. And if you don't have extra handles in your bag, what are you going to do? Or maybe the threads are burnt, whatever the situation may be. So that's, you're going to have wire brushes, maybe a file in there. If it's a PRD or a restricting device of some sort, does it take a tool to get it off? It might be a simple hex head, but the average firefighter, the abstinence of that is going to go after it with a Halligan or something like that, and you can damage the valve. Right. So it's not about brawn, but what you want in that bag is based on your pre-planning. If it's a particular manufacturer, like our IRFA valve, right? If you don't have the tool to take and loosen up that plastic shroud that goes around the control thing, you're going to go after it with a tool and possibly damage the valve. So once you get all that done, you've got it open. It only makes sense to have another gate valve under there so I can get the maximum the system has to give me under my control now. Because whatever you had to do to overcome it to turn it on, you're going to have to do to adjust it. So put on the gate valve right there, right? That's the first thing that goes on. And when I talk about it being regional, there's different adapters, different threads. Obviously, you're going to have the adapters. East Coast is probably one of the worst areas. I work with, Hudson County outside of New York City, and they're carrying 5 different threads in their bag. It's crazy, and it's space and it's weight. But the core critical things we have in there, we have the gate, we have the elbow, we have an analog pressure gauge. And much past that, a couple spanners, it's going to be your world. If there's particular tools, I've seen companies, Steve Robertson in Columbus, I actually use a picture of his Standpipe bag tools is driven by the design and manufacture of valve that they most frequently go to in his response district. So he has the correct tools to overcome all that. When a job goes that far into their pre-planning, that's where you're going to have, the probability of a bad day all of a sudden. It's, we can overcome this.
Right. So one of the products in that bag that you mentioned is an elbow. Yep. And I love the fact that in our industry, we look to be innovative at times. We look to create new products. Sometimes we, in a silly way, overcomplicate things. But now and then we hit with a product because there was a problem. And someone brought that problem to us and said, we need a solution. I think there's a great story behind the drain elbow that I've heard you tell before. I'd like you to tell that for the audience.
Yeah, it was it was the result of feedback from one of our larger urban partners, and major fire department in the Midwest, and at a standpipe fire, a working standpipe commercial fire. And the attack team from the squad is engaged in the fire, and a steel man door closed on the line and stopped the flow. And the control firefighter, the person at the valve, is they're calling a mayday, which means we're in trouble here, and have no water. And that guy's looking at a rock hard line. So it's like how to figure out what to do. They ended up having to close the valve down to get it out from underneath the door. So the whole bleeder, most people think it's there just so you can direct the water when you're picking it up and not get wet. Well, that's a big part of it too, but you can relieve enough pressure to take care of the hose being an issue without actually shutting the valve down. Because the travel time between the floor below to where the problem is, you shut the valve down and I have to go up another flight or so of stairs to get it out from underneath the door. If I get the door open, they still have no water. So ideally, if we can keep the valve open, relieve enough pressure to deal with something like that, that's why it was designed, based on a particular fire. And that's a game changer. And I agree with you. That came, out of what could have been a catastrophic event. Oddly enough, another thing that we have in the bag, I had some interaction with that same fire department. They were never an advocate for having a gate valve in the bag. So no need for it. And a captain was at a fire, and they were detailed. His company was the valve control, and most valves have a rubber sheet in the bottom of it, and over time that can age and crack. And they had a problem with the stretch, and they needed to shut the valve down to fix the stretch, and they couldn't shut the valve down because the rubber seal had cracked. So had they had a gate valve, problems would have been solved, but So it took a company, I think, almost the better part of a full bottle to deal with the hose problem. And I think they ended up only finding out that they had actually stretched short. So yeah, those little things, but it's like the same thing we're talking about when we're testing the fire engine in the street. It's a series of small things that require the average firefighter to have a working knowledge of what they're going to come across.
Right.
And in the absence of that, most companies, especially, this could be the fire of your career. They're going to put the new guy on the valve. That's a big mistake. You probably want your most senior engineer, the driver, as that valve firefighter,
Right.
because you're replicating the pump in that valve.
Good points, Jerry. And we always end the podcast with top threes. So of all the subjects we've talked about today, between the know your flow and the standpipe operations, for both, maybe give us your top three suggestions or takeaways.
I'll go to one of my standards. The reality. You better take into consideration the reality of the people factor. You can only engineer so many solutions out with a piece of equipment. It has to be simple and intuitive enough for the average firefighter to deal with it. And, that approach every change in the fire service or equipment spec in the fire service with that background of the reality of who you work with on a daily basis. Second, I guess, would be, and we accomplish this in going through the know your flows and the hands-on that we do, is accuracy matters. The thumbs up, thumbs down is contributed to many injuries and deaths.
Right.
Accuracy is, we do an analogy, and I'll throw this in the class. When we ask the entire group who knows a police officer, and everybody will raise their hand and then we say, I want you to think of the dumbest cop you know. Do you think the dumbest cop you know could tell you how many bullets are in their sidearm, what caliber it is? They can break it down and clean it, put it back together. It's a condition of their employment. They have to certify the range with it. That's their weapon. How many of you have the same depth of knowledge with your attack package?
Right.
And then understand that, in a career of 20 years, how many times the cop going to break leather and shoot somebody compared to how many times you're going to cross the threshold hoping you have enough water. You're fighting fire with an equivalent of a mask malfunction Mikey. You're pumped by preset PD. And you had an inexperienced boss call for the wrong line size, and you just hope you live through the event.
Right.
Reality is a factor.
Yep.
And then the third is use your lifelines. I mean, brass tacks, hard facts, Recon, the scientific side of the fire service, why you need to flow a certain amount of water, and how can I do it with the least amount of nozzle reaction to give my crews a chance to win. At the end of the day, we want to be effective firefighters. We want to make grabs, save lives. That's our job. But you can have the best commitment to being an effective firefighter, but with the wrong tools and accuracy, you're not going to get the job.
Right. Great stuff today, Jerry. And again, really appreciate your time and coming
my pleasure.
And sharing everything. Jason, final comments as we wrap up here?
I'm going to hit hard with a final thought. So we could have a whole class or a whole podcast on how fires have changed. Mm-hmm. It's a fact. We all know that fires, the materials that are in there, the houses are more buttoned up. They're burning hotter. We need the right amount of water to protect our people. And what I'm going to say that is maybe a little harsh, there's no excuses. I don't want to hear the excuse of my equipment's old. Your equipment may be old. It'll still work if you take the time to learn how to work it properly. The tools are out there. You don't have to spend the money. It would be great to have a whole flow package we talked about 3 pressure gauges, a flow meter. Little volunteer fire department probably can't afford that. But the resources are out there for you to get the help and learn the right way to do it so that you don't get someone hurt. Take advantage of it.
I would agree.
Yeah, great stuff tonight. And thanks again, guys. So this wraps up another episode of Rig Recon Live. Again, follow us on social media. You can find us on Facebook and Instagram. It's at Rig Recon. Catch this podcast wherever you get your podcasts, including YouTube. And most importantly, visit our website, rigrecon.com. Until then, suspect the best.